Yes, thank you. Okay, so this is the wrap-up session for the mini sprints. We had, I think, like counting like 1, 2, 3, like 7 different clusters of people working on stuff. I'm gonna report out first because I was in one as well, and then we have a line of people who are gonna do 1 to 2 minute report outs of what we did in our cluster. So in my cluster, we had 2 mini sprints. One was mine on making worksheets around Python syntax and other sort of drill education things that we need from a language standpoint. And then we also had Mason Eggers. Did I get that right? I hope I did. Cool. Got a thumbs up. On can you yell the name of your website? Unlocked edu. Unlocked.edu, in fact. Unlockededu.org is the correct version of there. We're trying to compile up multiple choice questions and into a website where you can access them and compile them together with an API. And so we all worked together to try and create questions, and we had a great time kind of coming up with a format that would work for these worksheets and brainstorming a lot of what should be inside of these workshops and really in worksheets and questions, and trying to come up with like what are the concept model of misconceptions that can happen in things like functions and for loops, and using that to kind of drive some of the content. And we have repos going, or at least I do for my project. We have repos of the style guide and license and contributor guide and a couple completed worksheets at this point. So, and templates worked out. So I'm really excited. All right, name and 1 to 2 minutes.
I'm Dylan, and the thing I was working on was doc test quizzes, which is essentially we're allowing students to take quizzes using the doc test module, which is a standard library in Python. Our project changed a lot in the last few hours. Initially, it was going to be a web app, and now we're going to be integrating Jupyter Notebooks as a plugin to Canvas, which is a learning management system. And yeah, I'll let you do the rest for.
I'm Adrian. What we did was we worked on kind of creating questions for the Python certification that Jeff talked about, and that like the MTA 98, whatever, 81 or I don't remember, but 93 or whatever. But anyway, that Python certification that people found very challenging and very difficult, like it was long and just like tedious. So we started creating questions. We have Sphinx running Runestone, so that we can just run Runestone build and have those questions out, and just we write the questions and then we can just check the questions. So yeah, that's what we did.
My name is Alex. I was working with the SensorCraft group over there, like the Minecraft game. One of the biggest things we worked on was we thought about making an installer. One of these things we thought of was a mutext editor implementation to make it a lot easier, because some of the people even in that group had a hard time downloading it and getting everything working. And so we can't really expect kids to do that then, so making it easier for kids to download. We also encountered a Retina screen issue with Mac OS, that the game would display at a quarter of its actual size, which obviously won't work, and so we got that fixed. We also learned about Pygame 0, which is like a Python-based game creator that lets you create really robust code to create games. And we thought about that and took some examples and thought of how we could apply that to SensorCraft, because we have about 900 lines, but we're trying to condense that as much as we can, again, so it makes sense for younger kids. We also talked about Blocky, maybe making some way that there's like an introduction that teaches you with block-based programming, and then you kind of transform into text-based programming, again, so that even younger kids can understand it and they kind of have a less steep learning curve. We also talked about explicitly defining prerequisites, so we use some big words like algorithm, mapping, that type of stuff. So just going through and making sure that the kids actually understand what we're talking about, and they're not just gonna lost and sit quietly in the back of the classroom and not raise their hand because they don't want to look stupid. So we went through and defined some of those things that we assumed that the kids would know. And finally, we also talked a lot about integrating into a school setting. So we had some teachers in our group that really wanted to use this in their classroom, but they have to use Common Core. And so we went through each tutorial and thought about what Common Core standard would this be hitting, what programming activity would this be teaching the students, and kind of made it a lot easier to integrate into a school curriculum, whereas before there wasn't explicit lessons for each tutorial. But thank you.
Hi, I'm Gabrielle, and I led a mini sprint on creating Jupyter notebooks to help high school students analyze scientific data sets. So we had a great group of sprinters. We had mathematicians, physicists, biologists, grad students, professors, coders, so a great group. And we split into 3 subgroups to work on 3 different notebooks, one on a coral reef data set, one on an earthquakes data set, and one on a very difficult to work with plant archaeology data set, so thank you for dealing with that one. And there are now 3 new Jupyter notebooks in a GitHub repository that are open source. Anyone can feel free to use them. I tweeted out the repository. If you're interested in it, just let me know. And they're still works in progress, but they all have a lot of great examples of exploring a data set, getting some questions you can ask about them, making data visualizations. So I'm really proud of what we came up with and look forward to seeing where it goes. Thanks.
Hi, I'm Shlomi. In my group, we work about developing learning activities for teaching programming problem solving. Think about the challenge students have after getting syntax and basic of the language, how I take problem and solve it end to end. So basically we are using a Jupyter notebook that starts with a problem and guide the students through solving the problem, like getting what is the problem, making design, code, testing, and debugging and reflecting about its work. Writing a walkthrough is really tough because you need to really design well the path you want the student will go through that. So we took one advent of code problem and make a design and break it into an outline. What is the path we want the student to go? It's include, for example, reasoning explicitly about a data structure you want to use. It's also includes strategies like simplification. I don't know to solve the original problem, so I'll try to solve a simplified one. So we make all of that explicit and embedded with activities in the middle for the students. And I'm very, very happy and think it was very successful.
Hi, my name is Ariel. I was leading a mini sprint on pair programming, effective pair programming with students. So we spent most of the time actually working on pairs so that we could have experience firsthand. There were 5 people in the group, and well, I decided to team with one of the other person so that we could actually have 3 teams in total. So we spent most of the time solving a group of problems that I originally proposed. Some issues happened on using the tool that we were basically utilizing. We were using an online judge to solve certain problems, and getting a hang of the online judge was a little bit of an issue in itself. But at the end, every team actually solved at least a few problems. So they were able to have firsthand experience on actually working with somebody else, doing the corresponding roles in pair programming, which is the driver and the navigator. So at 4 o'clock we stopped and we had the opportunity to fill in a survey, an online survey, so that we could actually have quantified the experience. And then we had a small discussion on the personal experience that we had using pair programming. We can see that there's still a lot of questions that we need to answer, but hopefully we should be able to have these issues solved, or at least we'll explore them a little bit in the coming months or in the full year in the future. Okay, thank you very much.
Sorry. Hi, I'm Ariadna, and I was working with the Raspberry Pi group, and I believe initially we were trying to work on a template that would help educators kind of set up like more of a simplified way to set up a Raspberry Pi, like an introduction, just like very basic stuff. And I think we decided on a template that is on DocuWiki that would allow educators as well as developers to contribute, but kind of bridge the gap so that educators aren't overwhelmed with like the tech language, but also be able to pull lessons and be able to translate them for their students, but without getting intimidated by not knowing how to use GitHub, that kind of thing. I think that's pretty much it. Okay, thank you.
Great. Can we get a round of applause for all of the mini sprint organizers? And another round for all of the participants as well, providing awesome help. So yeah, this was an experiment to run this year, and I was really excited to get down to business and get some stuff done. I think we got a lot of really cool stuff worked on and some new experiences. And do you want to have some final comments, and then we can all go and get prepared for the lovely opening reception.
Yes, so thank you everyone for attending, and it has been something new this year, has been pretty successful, so we are quite happy about that. We will now be sitting down and preparing for next year's summit. I would really appreciate feedback. Please feel free to send it to PyCon Edu Summit, the email address that's on the website. And if anybody is wanting to volunteer or wants to know more about the programs or the talks that were mentioned today, please feel free to reach out. Hope to see all of you next year in 2020. Thank you.